Musk hesitated for a moment, but behind that brief pause was a transformation already reshaping the automotive world. Right now, the production system for the 2026 Tesla Model 2 is smashing expectations that every legacy manufacturer once believed were unbreakable. The line is operating at a blistering pace of 3,000 vehicles a day, moving through welding, pressing, and assembling with a level of accuracy that feels closer to scientific precision than traditional car building. What exactly is powering this? And is this radical assembly line truly capable of pushing Tesla beyond global giants like Ford, GM, and Volkswagen? Over the next few moments, we'll answer both questions using the newest performance metrics that show why Tesla's manufacturing ecosystem has become nearly impossible for others to catch. The enhanced gigapress alone operates at an enormous 6,500 tons of clamping force, forming entire underbody structures for the Model 2 in a single cast that replaces more than 200 weld points and slashes defects by over half. The result is a frame that's more than 30% stiffer, giving the vehicle handling stability that old-school multi-piece body construction can't match. Operating at more than 1,100 degrees Fahrenheit and using high-grade American aluminum, the process delivers close to 97% material efficiency, saving hundreds of dollars per unit in wasted scrap and pushing those savings toward customers in states like Texas. Across the floor, fleets of ABB robots, 850 in total, shift tools in under 10 seconds and can switch from welding to bolting to inspections automatically. These units handle more than a dozen Model 2 variants every shift while maintaining bolt accuracy above 99%, cutting alignment issues dramatically and proving their reliability in harsh environments from Nevada to Florida. Real-time inspection using laser scanning systems catches microscopic inconsistencies instantly, reducing correction times and boosting first-pass quality to nearly perfect rates above 99.7%, far surpassing the 97 to 98% averages found in major legacy EV plants. Materials flow through the line on automated carriers, moving almost twice as fast as traditional systems, erasing downtime between assembly segments and keeping production continuous instead of stop and go. This entire ecosystem, gigapress precision, robotic adaptability, and intelligent material logistics, allows the line to push out about 960,000 vehicles per year when scaled, an output level that redefines mass manufacturing. Innovations extend even further with battery installation platforms that shrink dock times from over 10 minutes to barely 2.5, enabling more than 350,000 installations annually at uptime rates that surpass even Lucid's advanced facility. Thermoplastic recycling loops cut waste dramatically and qualify buyers for sustainability incentives that lower ownership costs from day one. Walking through this line feels like stepping into the future. Machines and humans operate in harmony, with robots handling repetitive precision work, while workers oversee complex adjustments and quality-critical steps. Rather than replacing craftsmanship, the system elevates it by removing the mind-numbing tasks that traditionally cause fatigue and errors. But machinery alone does not fully explain why Tesla is pulling ahead. When comparing this line's performance to Ford's F-150 Lightning production, Volkswagen's ID.4 factory, or GM's Ultium-based EV operations, the differences become staggering. Tesla's daily output nearly triples Ford and more than doubles Volkswagen, and its cycle time from raw chassis to a completed Model 2 is only 7.5 hours, almost half the industry's 12 to 14-hour norm. Faster assembly doesn't translate to shoddy construction. The exceptionally high first-pass yield shows the opposite. These quality improvements mean fewer calls, fewer early service visits, and greater long-term reliability, all of which translate into stronger resale value and higher customer confidence. Material usage is so efficient that scrap rates fall below 1%, and energy usage per vehicle drops nearly 20% compared to traditional EV facilities. Water use in stamping and painting is also significantly reduced, lowering both environmental impact and operating costs. Human-robot collaboration is optimized so each worker oversees more than a dozen robots, compared to roughly half that at other automakers. This dramatically reduces labor strain, minimizes mistakes, and channels human effort toward precision-dependent tasks that automation can't perform alone. Tesla's modular production cells allow instant reconfiguration between variants, avoiding the weeks of downtime that cripple other automakers whenever they switch models. Predictive workflow algorithms keep bottlenecks from forming, and even unexpected slowdowns get absorbed without derailing the entire line. All of this creates a manufacturing template that Tesla can duplicate worldwide with minimal retooling. Instead of spending a year reworking a plant for a new model, Tesla can pivot in under an hour. That stunning flexibility can cut factory setup expenses by nearly a third and accelerate global EV rollout in ways legacy companies simply aren't prepared for. The environmental advantages stack on top of the economic ones. Almost zero scrap, dramatically lower energy consumption, and sharply reduced water usage form the backbone of a production strategy that forces competitors to rethink their standards or face falling permanently behind. Tesla can bring new models to market up to a year faster than traditional automakers, meaning buyers get upgrades in battery chemistry, safety structure, and software systems long before rival brands can deliver. Wait times have crashed from nearly a year to mere months, giving families and retirees the confidence to order without worrying about endless delays. Structural rigidity rises by around 20% thanks to precision welding and continuous real-time inspection, meaning fewer defects, fewer returns, and a safer driving experience that lasts. Tesla's production line isn't just faster or cheaper. It's a blueprint for the next era of global EV manufacturing. The companies that adopt similar systems will survive. The ones clinging to outdated, rigid processes will fade. And for buyers, this shift promises better vehicles, shorter waits, stronger safety, lower long-term costs, and reliability levels the industry has never achieved at this scale. The future of EV manufacturing isn't coming. It's already humming on the floor of Tesla's Model 2 production system, forcing the rest of the industry to adapt or disappear as Tesla keeps redefining what modern auto manufacturing can be.